Hey, this is Math Minutes Pro with Dr. Harrison. And today we're going to talk about transforming linear functions or linear equations that are graphed in a coordinate plane. The coordinate plane is the XY axis. So we have two sets of instructions here. And first we're going to graph f of x and g of x. And that just is a notation to communicate that we have a function. And then we're going to describe the change from f of x to g of x. This topic does come up in Algebra 1, but it also comes up in geometry. It involves spatial visualization. And remember, we have a function when we have a case where for every x value, there's exactly one y value. Or if we draw a vertical line through the graph, that vertical line hits the graph at one point. That is called the vertical line test. That is proof that we have a function. So that's what we mean when we say transforming a linear function. We're going to transform or change a linear function or graph. All right, so let's start where we're going to be given two functions. So I'm going to write that information over here. We have f of x equals x, and then we have g of x, and that equals x plus 3. So first thing we want to do is graph f of x and graph g of x. All right, this should remind you of the slope-intercept form. Okay, so let me go ahead and write that down. We're going to use the slope-intercept form, which is y equals m times x plus b. We're going to use that to graph these two equations. All right, so let's start with f of x equals 0, okay? Excuse me, f of x equals x. Now, in this case, there is no this is m is the slope and b is the y-intercept. There is no y-intercept, so I'm just going to write plus 0 there to communicate that b is equal to 0. Remember, so let's start with this one first, g of x. Now, first thing we do is we plot the y-intercept, and in this case, the y-intercept is 3. So let's go ahead and do that. Y-intercept is 3. I'll put a point right there. Okay. And then the slope, which is in front of the x, is 1, which is 1 over 1. So we're going to start from here. We're going to rise 1 and run 1, because in order to draw a line, you need at least 2 points. Okay. So again, we plotted the y-intercept at 3. And then the slope here is 1 over 1. It's 1 over 1. So we start from the y-intercept, go up 1, positive 1, and then go over 1, positive 1 in the x-axis. So now that we have that, let's go ahead and get our line sketched here. Okay. Okay. There we go. Try to make it a little thicker so that you can see it. There we go. All right. Now, some teachers will ask you to write the equation of the line next to it. So I'm going to write y, I'm going to write g of x equals x plus 3. All right. Now, let's graph the second equation, which is f of x equals x plus 0. So the y-intercept is 0. The slope is 1, the coefficient in front of x. So we're going to start from the origin. We're going to rise 1 in the positive and then run 1 in the positive. Rise 1 in the y direction, run 1 in the x direction. Plot the second point. Okay. And use our straight edge. And let's get that second line drawn here. Okay, there we go. All right, and I'll go ahead and write the equation of that line, which is f of x equals x. Okay, so we did the first part, which is to graph f of x and g of x. Now it says describe the change. See, now let's talk a little bit about change in a coordinate plane. You can have a reflection where you reflect something across something, like a point can be reflected across the y-axis, or a shape can be reflected across the y-axis. A point can be reflected across the x-axis, or a shape can be reflected. So that's one of the transformations. A rotation means turning. Think of the hands on a clock. That's rotation. And then translation means to slide. All right? When you take a shape and you slide it. Those are the three types of transformations: rotation, reflection, and translation. So here it says examine the change from f of x to g of x. This is the line, the red line is f of x. So let's see, what would have to happen to move this line here to there? Is that a case where we reflect this line? Are we turning the line? Or are we translating it? To translate means to slide. Well, it's not a reflection, and we're not turning, it's not a rotation. Yes, it is a translation, okay? So the first thing I'm going to write is translation. Translation. All right? All right. And that translation, and I'm just in case you can't see it, I'm also going to write it on here. So we have a translation. Now, that means we're moving it. Are we in f of x? We have to move it up. How many units? Let's count. Start from here. 1, 2, 3. And then that f of x would be right on top of the g of x. All right? So we're going to say a translation 3 units up. Translation 3 units up. And that is an example of how you do what? First, you graph f of x and g of x, and then you transform the linear function. In this case, we determined that it was a translation where we had to slide it or move it up. How does this relate to real life? Well, sometimes when you're playing video games, right, you see an object in space or on the screen, and Mario Brothers, I don't know, in different type of games, and you may see a figure move from left to right. That's a translation. Or you may see a figure turn counterclockwise. That's a rotation. So here we see learning this concept of transforming a linear function can get you ready, possibly, for a career in video game design. Okay, so we saw a case where we transformed a linear function through a translation. Let's see what it looks like when we have a rotation. Okay? All right, so let's go ahead, all right, and provide 2 equations or functions, if you will, for us to consider. So let's say we have f of x, and we say that's equal to 1/3 times x. 1/3 times x minus 4. And then we have g of x And that is equal to 1/4 times x minus 4. All right, so just like we did before, we're going to follow these instructions. We're going to graph f of x and g of x, and then we're going to describe the change from f of x to g of x. So let's go ahead, and I have our slope-intercept form here, y equals m times x plus b, where m is the slope and b is the y-intercept. So we're going to plot the y-intercept first, and then we're going to use the slope to get to the second point, and then we're going to draw our line. Okay? All right. Let's start with the first one, f of x equals 1/3 x minus 4. Well, we see the y-intercept is -4, so we start here from the origin, go down -1, 2, 3, -4. And then our slope is rise over run, rise 1 and run +3. Start from here, rise +1, and then run +3. 1, 2, 3. And that is how we plot our 2 points. Now we are ready to go ahead and draw the line. So let's lay that down there like so and get our line drawn through the 2 points. Like I said in the last problem, some teachers will ask you to put the equation or the function next to the graph. So I'm just going to write it right here. Let's see here. I'll write it above rather. F of x equals 1/3 times x minus 4. Okay. Now let's graph g of x. Okay. So again, the y-intercept is -4, so it's the same thing right here. And then the rise is 1/4. Rise is 1 and run is 4. So I'm going to rise 1 and run 1, 2, 3, 4. Okay? All right, so let's get that line drawn. And I'm doing it with a red line this time. Okay, that is g of x equals 1/4 times x minus 4. So we have successfully graphed f of x and g of x. Now let's describe the change from f of x to g of x, from the purple line to the red line. Remember, there are 3 types of transformations: rotation, reflection, and translation. Let's see if this is a translation. A translation is like we had before, where you have the purple line. Are we sliding it in order to make it the line be transposed on top of the red line? No, that's not the case. Are we reflecting the purple line in order to put it on top of the red line? No. Actually, we're turning the line. If you take this purple line like that and then you turn it clockwise, then this purple line would be directly on top of the red line. All right, so we're going to call that a rotation. Call this a rotation, but I think we can be even more detailed. Rotation about, and we're rotating about what? We're rotating it about this point right here, which is 0, -4. So we're rotating the purple line, f of x, right? And I'm going to say rotation clockwise about 0, -4. And there you have it. We have successfully transformed the linear function f of x to g of x. So thank you for watching. If you found this video helpful, remember to like, comment, and subscribe. And don't forget to check out my Patreon page on my video description below. On my Patreon page, you can get access to exclusive math lessons, study tips, live Q&A, and more. See you next time.